Hey everybody, so welcome to GraphQL Bangkok 13. I was here last two times as well, so who was here before? Who came to the last one? I remember your face. I remember some faces, but everyone else is new? Okay, welcome. And I'm glad that everybody turned up. Let's see. Cookie, okay, great. So my company is called rconnect, and we work with people and companies in open source. So we have a bunch of open source libraries. We attend a lot of these events, and we foster communities for our open source work. I'm from UK, as Tobias mentioned. I love tea from these lands, but I do spend a lot of time. I do spend a lot of time in Thailand, so I do like this country quite a lot. Something interesting that I thought I'd put on the slides today is a friend of mine the other day, Taiwanese. He showed me his passport with the UK stamp, and of course, as I go into the UK, I don't see the UK stamp. So maybe Thai people here, you don't see what the Thai stamp looks like. So this is what happens when a foreigner comes into Thailand. Quite interesting. And you see that I like Thailand quite a lot. So it's super tatted. So these are like my stamps. So I do like a lot of code. So I worked at Prisma, I worked at Neo4j. I've worked on all the open source stuff on GraphQL. And we also have our debugger solution as well. So I'll show you a little bit about that at the end of this talk. These are all the meetups that I co-organize. So just last week, we had Singapore. A couple of weeks ago, we had GraphQL Taipei. Bangkok, this is the third one in the year. So if you're interested in GraphQL meetups or want to start one in any city in the world, then just reach out to me after this event. So let's get on to the talk. So Neo4j and GraphQL. Who's heard of Neo4j before? A couple of you. Are you using it in production, or like what? How are you going about Neo4j? You just heard about it. We're a silent crowd today. All right, nice. So I'm going to give you an introduction to Neo4j. Then we're going to go over how to use it in the driver. I imagine most of you are developers, so I'm just going to dig into the code and show you how to use Neo4j there. And then I'll show you their GraphQL library, which basically you can use Neo4j with GraphQL with quite ease. So let's get started. So Neo4j is a graph. So completely different to how your databases, how you use SQL databases, relational. Here we have nodes. So you can think of these as tables in a relation world. So we have a movie table. Can I use a pointer? Oh, yeah, we have a movie table and a persons table. And I've downloaded Neo4j desktop. So you can go to Neo4j and download the desktop, or you can run Neo4j in Docker. But I've got Neo4j desktop, which is free. You can download for free. And then you can start a database and open what's called Neo4j browser. And this is basically like a SQL workbench, but for Neo4j. And then I can issue queries and see the results. As I mentioned, everything is nodes, right? We start with nodes instead of tables. So let's just have a look and see how we can query nodes in Neo4j. So I'm going to match all the movies and return the movies. There you go. We have all of our nodes plotted in the graph. And I had some like seed data in here before just to get going. And we can play around with Neo4j browser and move these nodes around, which is quite fun. And of course, in our database as well, we also have people as well. So I can match the people and return the people and query that. And then we get a lot more people as well in our graph. But when you're thinking about graphs, there's no point in having a graph if you just have nodes on their own. They don't really mean anything. You might as well just have a NoSQL database at that point. So the real power comes with relationships in graphs. So these are basically, you can think of this as like a foreign key relationship in SQL. But instead, we have a fundamental core database principle called a relationship that we connect two nodes together. And I'll show you what it looks like if we just match everything inside Neo4j. So instead of just matching the people, I can actually match all of the nodes with any label. I hope you can see that. And return everything. And now you'll see that this is the graph that we have. If I zoom in, you'll see that we have Bonnie Hunt acted in Jerry Monroe, whatever, how do you say that word? So this is where the real power comes in graph with these relationships, and these are actually stored on disk as pointers in memory, so they're super efficient to traverse. And you don't need anything like a foreign key to connect them together, so the relation is the actual relationship itself. And of course, like your standard databases, you want to add properties and values to your graph or your data model as well, so you can add key value pairs to your nodes and also relationships as well. One of the powers of having a graph is that you can traverse those relationships with ease using the Cypher query language. So I'm going to show you a little bit of that power now. So let's go to here. Let's get rid of this. Yo. So let's match the matrix. Okay. Oh. Did I do that right? Oh, is it title? My bad. Title. There we go. Okay, so we have the matrix movie. I'll go to graph view. There we go. So if we wanted to find out all the actors that worked on the matrix movie in a relational database, then we'd probably have to use like a lookup table or something and do like a cross join to the movies, acted in movies, so on and so forth. But with graphs, you can basically draw your pattern in the query language itself to retrieve those relationships. So I've already matched the movie, but maybe I want to find out all of the actors that acted in the matrix. And so here I can use the Cypher query language to expand out the relationship. And it's an inward, so people act in movies. So I'll point into the movies, and then I'll find all the people with the label of person. And if I return that, you'll see that now it's traversed that relationship for me super quickly, and it's found all the people that act in the matrix. So that's like a brief primer to Neo4j Desktop and Cypher the query language and how graphs work. Does anybody have any questions? Anybody confused? Oh, you have a question? Yeah.
Just the visualizer, what's its main use case? Like, okay, it's fun and all to look at the data right here, but this is a small amount of data. I imagine when you have millions of records, it's not going to be very beneficial to just look at a lot of dots. Or is there a possibility to look at those dots and drive some conclusions just out of the way they're connected? What's the use? What are the use cases of this? Other than just
Sure. So this Neo4j Desktop is designed for developer use. So if you had like a million nodes and you tried to display them in here, it'd probably crash. But Neo4j actually have something called Bloom, which is like a data analysis platform for visualization. And you can like visualize up to like 10 million nodes or something like that, and it will highlight anomalies in the graph for you. Let me just find that for you, Neo4j Bloom. Oh, did I? 1 second, I need to connect my phone again. And Neo4j Bloom as well, you can also use through the desktop. So you download Neo4j Desktop, and then they have a bunch of apps inside of desktop called Graph Apps. So you have the browser, which we've already been using, or Bloom, or maybe I can start it. Did I start it back?
There's a table view as well, right?
Yeah, there's a table view. So you can query nodes and just get like the whole node object back, but you can also project like a JSON structure back like this as well. So it's very easy if you want to map it. Yeah. Yeah. Anyway, I'll keep on going. So where's my slides? Oh, I was going to look at Bloom. Excuse me, guys.
Sorry, so that's an extension to Neo4j that I can use.
Yeah, check it out. Yeah, I won't hold up with everything. Okay. So that's your primer to Neo4j. You can basically use it like a standard database, but it comes with like a bunch of superpowers because it's stored in a graph. So you could do like machine learning, graph analysis. You can traverse those relationships really quickly. For example, if you have a shop and you want to find recommended products, you just draw one line basically in Cypher, and then you find the recommended products. So it's cool. You can use it as like a general purpose database and then build up and add all of these extra features as your product scales. But this is a GraphQL meetup, so I wanted to show you Neo4j GraphQL. I was actually the first contributor to Neo4j GraphQL, so I wrote the foundations of this library, so you're in good hands with this talk. And essentially, it's designed for front-end developers who don't know Cypher, the query language, or who also don't know database concepts. And you just, as long as you know GraphQL, you can basically get started with Neo4j quite easily. I'm still having internet issues, but we'll just continue to code. Okay. So driver. So I thought I'd show you a quick example of how to use Neo4j with the bare bones driver. So it's quite easy to get started. You just point to localhost, then you spawn a session, and then you can run your queries in that session, and then basically just map the records back into something that's familiar, so node driver. You'll see that we get something a little bit ugly. Of course, when you're reading raw from the database, you always have to pass all of the values into something that makes sense in your application layer. So Neo4j GraphQL tries to solve that by giving you all the power of the graphs through GraphQL API. So the way that you get started is like this. So you use GraphQL schema definition language, and you define your nodes as types. And then you use what's called a GraphQL directive, which is this at relationship, to annotate the core database relationship between those two nodes. Then once you've done that, you construct your driver, and you pass both the type defs in the driver into the Neo4j GraphQL engine. This will basically iterate over each of the types in those type defs and generate for you a bunch of resolvers, CRUD resolvers, aggregate resolvers, relationship traversal. So you don't have to write any resolvers yourself. So you'll see here that I start Apollo server and start Apollo server, and there's not a single resolver defined in this file. And let me just start that now. Start that up. So again, basically the only input that we gave it was the structure of our graph through the GraphQL schema. Then I can come to Apollo server. Apollo server is in the cloud. Apollo Playground is in the cloud, so I am offline. I'll try again. Is it? Thank you. Do you know the password?
I think it's open.
Apple guest. Let me just see if my phone works once more. Right. Apple guest, yeah?
You can try and do it this, for that case.
Oh, it worked. Ah. All right. I think it's loaded now anyway, so we don't need that anymore. So we just gave Neo4j GraphQL engine a bunch of type definitions, and we have this API that's been generated for us. So we can explore through the schema, and you see that from the type movie, the type person that I declared, you'll see that there's 6 queries and 6 mutations and 25 objects that have been generated for me. And because I've supplied the driver to it as well, I can just start querying Neo4j via my GraphQL API. So let's just check out some queries. So let's say we want to find all the movies and the title of every movie. Well, we can do that. And then we can also traverse the relationships. And so we can say that, give me all the name of all the actors in all the movies as well. And if I run debug mode, so if I debug star, and then issue another query wherever my browser's gone, you'll see that what the library is doing under the hood is matching a movie, and then it's generating a subquery for us, traversing that relationship based off of the annotations that I've given in the schema, and then map the results to something that GraphQL can accept. Does anyone have any questions? Go ahead. Yes, it is. Yeah, but they're building a cloud, so they're going to solve that problem for you in their cloud. Did someone have a question over here? Go ahead.
Yeah, what do you mean in the cloud? I cannot run it on my...
Yeah, no, this is running on my local machine, but in terms of caching the queries, they're building a hosted Neo4j GraphQL solution for you, and that will have caching and advanced features in it.
Oh, right.
But you could always add your own cache layer in front of this, right? You just cache the GraphQL query and the result. Go ahead.
Working with SQL and GraphQL, it's like you fetch all the records from the database, but you only return what's needed.
Mm-hmm.
So with Neo4j, is it like projection that you pass in only the records or the fields that you need, or
Yes.
you fetch all and then you do the the conversion or the translation and then you return?
So let me just have a look at that generated query, because yeah, okay. So they just to see if they changed it since I last worked on it. They take the resolve info object from the GraphQL resolver, and that has all of the selected GraphQL fields. That then gets reflected into the Cypher query to ask for exactly what you need. So you can see in this query here, if I just go back to the browser, sorry, I'm getting lost with the browser. Let me put it here. So my GraphQL query is just movies and title. And if I go to the console, you'll see that we match the movie, and then the projection, the return statement is literally just selecting the title from the database. And then whereas, if I added released, I don't think there's any other values. I haven't defined anything else in my schema to expose, but maybe I can show you that. So a movie also has released, which is an integer, I believe. I'll refresh that. So now we get the released, and you'll see that the query is now selecting the released as well. So it just asks for exactly what you need based on the GraphQL query. It's generating the specific Cypher query in the GraphQL layer to only return the specific values from the database. So it's happening in both places, sort of. Any other questions? Cool.
That's your library, right? You help create.
Yes. So it's completely free to get started. So you can go to, they're on GitHub. Just go to neo4j/GraphQL. I don't think I have any internet to show you, but yeah, check it out. It's free to download. You just need to download Neo4j desktop, start a database, connect it to the library. You need well, let's have a look at this API. This API is built in 42 lines of code. Less if you take out the white space and you have a full functional GraphQL API. Mutations, connections, relationships, aggregations, authentication. is all built in there as well. And so I'll just go back to my slides. So that's it from the Neo4j. As I said, I have a company called rconnect. We're based out of London. We're also considering moving some business here to Thailand at True. So if anybody does want to work with us or they find some of our work interesting, then reach out to me after this. We bought a bunch of domains as well in the GraphQL space and put projects behind them. So I actually spoke about GraphQL Debugger last event, and we just purchased GraphQL AI and put some cool tool. Right, yeah. I'm selling this for $10,000, so if anybody wants it, then they can have it. But go check out those and have a play around with them, or just ask me any questions about them. And you can visit our website at rconnect.tech. Maybe there'll be a .th at the end of that as well, some other time. And that's it from me. So thank you very much for your time.